Okay, this is lesson 1-3, writing expressions. This is a pretty easy lesson, and we're going to start with the chart that you have on your notes that are right in front of you. The chart shows you the different operations: addition, subtraction, multiplication, and division, and it gives you words there that represent those different operations. For example, addition, you have sum, plus, total, more than, increased by, more than, they go together. Subtraction, you have difference, less than, minus, and decreased by. Now, I want you to underline the word less than. It is the one that's going to be a little bit different than the rest of the subtraction problems, okay? For multiplication, you have times, product, multiplied by, and of. Of is a biggie, circle it. Anytime you see the word of, it means multiply always. And division, you have quotient, divided by, and divided into. The next column, you see some verbal phrases. So let's go through these verbal phrases and see how we write the expressions. Okay, the verbal phrase, the sum of 2 and a number x. In other words, sum is our keyword, meaning addition. We are adding the 2 and the number x. So it becomes 2 plus x. Okay? And then obviously the next one, a number n plus 7. That's very simple. It's obviously n plus 7. Now, the thing about addition is it's commutative. It does not matter the order that you write these in, even though in the sentence n plus 7 comes first, 7 plus n will give you the same result because it's addition. Okay? With subtraction, it's a little bit different. You don't have that luxury of just being able to write it in any order. So, when you're writing a statement like this for subtraction, the difference, you know, it's subtraction of a number n and 6. Okay, the n has to be written first because it's first in the sentence, and the 6 has to be written second because it's second in the sentence. Must be specific order. Cannot be 6 minus n on this one. Okay? All right, now the reason that we underline less than, and I want you to underline it here as well, underline less than, it is the one that is different. Okay? All right, so the less than is a little bit different because of this right here. So hopefully you've underlined it and started it, because this is the one you're going to have to remember. This is the only one that's different. When it says 8 less than a number k, it's the one time where you swap around. What's second comes first in the problem, and what's first comes second in the problem. Okay, does that make sense? You see what I'm saying? So when it says 8 less than a number k, that's when you're going to actually like flip it around. K minus 8, because the number k needs to be reduced by 8. It's 8 less than that. Okay? All right, multiplication is pretty simple. 12 times a number y, 12y, 12 times y. 1/2 of a number x. You can write 1/2 x, or you can write x divided by 2. Either way, okay? Because x over 2, in other words, it looks more like this. Or you can write 1/2 x. Either way is correct. And then division, obviously, is fairly easy. The quotient of a number k and 2. Again, the quotient, whatever comes first, is going to be on the top of the fraction, and whatever comes second will be the denominator of the fraction. Okay? So the quotient of a number k and 2. Now, you can write it like this. Okay? K divided by 2. But as algebra students, we need to get in the habit of writing them as fractions. K divided by 2. Or like this. K divided by 2. That's how we need to get in the habit. This is a division problem, just as this is a division problem. Okay? All right, moving on. Now we can start filling in some of your notes. All right, some some examples, Examples. Okay, here's the verbal phrase. For less than, oh, there's that phrase. There's that phrase less than. So underline it, star it, whatever, okay? For less than the quantity, there's another keyword, 6 times the number n, okay? So the first thing we need to do is we realize we have a quantity. So think of order of operations, and the quantity, 6 times the number n, has to be grouped together, and then you subtract 4 from that quantity. Okay? All right, letter B. 3 times the sum of 7 and a number y. Okay, so 3 times the sum, so we're going to do 3 times the sum of 7 and a number y. So here we go, let's look at this. All right, since y is not an actual number, it's a variable, we have to write the sum such as this, 7 plus y. Now, since it's 3 times the sum, we have to have the parentheses, because we're going to multiply the 3 times the sum once we know what that sum is. Right now we don't. We just know it's 7 plus y, and we can't take it any further because we don't know what y is. Okay, letter C. The difference of 22 and the square of a number m. So here we go with difference, so it doesn't matter. We're not going to switch orders, then less than, like we switched orders. We're not going to do that. The difference of 22, so what comes first in our sentence is going to come first over here, and what comes second in our sentence will come after the subtraction sign, and the square of a number n. So here's our square of a number m, and the difference between them, 22 minus m squared. We only flip it around on less than. Okay, let's do some guided practice. Please pause the video, and you can do your guided practice, and then you can check your answers. Okay, for practice 1, translate the phrase, the quotient, when the quantity 10 plus a number x is divided by 2 into an expression. That sounds very, very tough, but let's think about it. We have a quotient, so we know we're going to have some division, and we have a quantity 10 plus a number x, so we have a quantity 10 plus a number x. We know we can't really add those together, so we're going to probably have that in parentheses, and we're going to divide that by 2. So let's see what that looks like. Hopefully you came up with this. The quantity 10 plus an x. Now, they don't have parentheses, but that's because within a numerator, there are understood parentheses. You cannot divide this numerator until this numerator is simplified. It's kind of like understood parentheses. Okay? All right. If you have questions on that last problem, circle it and bring those to class. All right, example 2, write an expression. This is a word problem, and I think on your notes you have something about verbal models. Okay, verbal models are something like this. A piece of ribbon, L feet long, is cut from a ribbon 8 feet long. Write an expression for the length in feet of the remaining piece. Well, this problem is going to give you some visual models. If you can't do a verbal model, you can always draw a picture. So the first example, or the first solution, the example they give you is, suppose the piece cut is 2 feet long. So you would know if the original ribbon is 8 feet long and you cut 2 feet off of it, the remaining piece would be 6 feet. So we're going to use that to help us solve this. Suppose the piece cut is L feet long, which is what we've been told right here. Okay? So here's our diagram. We're going to draw a picture. Here's our ribbon that's 8 feet long. We're going to cut 2 feet from it. Obviously, this remaining piece would be 8 minus 2, or 6 feet. That should help us solve this one. Okay? So let's substitute the L in for the 2. So put that L in for 2, because we don't know how large the piece is. It says L feet long. We don't know. It could be 5 feet. It could be 1 foot. We don't know. So we're going to put that L in for the 2, and in the same way, we're going to put the L in for the 2 here. So there would be the expression of the remaining piece, 8, excuse me, 8 minus L. Over here we have 8 minus 2. And over here we have 8 minus L. Just showing you the two different expressions. How we used a number to help us solve that, and then we substituted that in with the variable, substituted the variable L in for that number that we used. Okay. Now, this is similar to a verbal model. It's also a picture model. Okay. This could be written as a verbal model. Now it's exactly, let's practice a verbal model. Okay. With tips. You work with 5 other people at an ice cream stand. All the workers put their tips into a jar and share the amount in the jar equally at the end of the day. Write an expression for each person's share in dollars of the tips. So here would be an example of a verbal model, not just a picture, but a verbal model. Okay? Amount in jar divided by the number of people. Now, I know this is really simple, but I'm just giving it to you because in your homework assignment, they're going to ask you to write a verbal model first and then write an expression. So once we know the verbal model, the amount in jar divided equally. It even says they're going to share, which means divide, the amount equally at the end of the day. So the amount in jar, translate the verbal model into an algebraic expression. So let A represent the amount in the jar. A for amount. Okay? So we're going to put an A right here under amount in jar. The number of people. Why is the number of people 6? Because right here it says 5. Okay? Hopefully you understand that the 5 other people are also with you. You get to share in those tips. So you make that 6th person. So make sure you're always reading the problem and know what you're doing, know what your numbers you're dealing with. So amount in jar divided by the number of people, 6. So there's our expression, and there is exactly how we should be writing it in algebra. A divided by 6. Okay, I hope you have that down on your notes. Verbal models. Now that seems like a very simplistic verbal model, but as we get into much more difficult expressions and equations, it will help to understand, write the things that you know verbally in problems. That will help you then substitute in what it is you know for each of those and what you don't know for a variable. Okay, some guided practice. Okay, we're going back to our example with the ribbon. In example 2, suppose that you cut the original ribbon into P pieces of equal length. Okay, original ribbon into P pieces of equal length. Write an expression that represents the length in feet. Now I'm going to go ahead and help you with the verbal model if you wanted to. Okay, original ribbon cut into pieces of equal length. So what operation would cut something into equal length? Divided by, and then how many pieces are we dividing it into? Dividing it into number of pieces. And they already give us the variable. Okay, so pause the video, and obviously you can write this if you need to pause the video. And you should come up with original ribbon L. I think you should have an 8 here. Okay, sorry about that. Cut the original ribbon, which we know was 8 feet. So it would be 8 divided by P, however many pieces you're going to divide that, cut that into. That would give you the length of each piece. Okay? So make sure this is 8 divided by P. The original ribbon was 8 feet. Number of pieces, P. Okay? All right, next guided practice goes to the example of the tips, well, of the workers. In example 3, suppose that each of the 6 workers contributes an equal amount for an after-work celebration. So now we're contributing an equal amount for an after-work celebration. Write an expression that represents the total amount contributed. 6 workers giving an equal amount of money. Okay, so number of workers and contributing an equal amount of money. I'm not sure of an operation yet. Let's think about this. My number of workers is 6. They're all giving an equal amount of money. So let's just kind of assume that they all give $10. Okay? And if 6 people give $10, how much money do you have? You're going to have $60. So what operation did you use for that? Hopefully you know that you used um, multiplication. Okay? So since we don't know the equal amount of money at this point, we need to assign it a variable because we don't know what everybody's contributing. It might be $1, it might be $5, it might be 10. So let's assign it a variable. How about A? It might be M. I'm not sure what the video is going to use or the PowerPoint is going to use. So our expression would be, they used D, I used A. It wouldn't matter. My expression would be 6A. There's a 6D, where D represents amount contributed by each worker. Mine is the A, amount contributed by each worker. Okay? Pretty simple, I hope. This is all just about writing expressions. Okay, grip your seats. This is going to be the hardest one we do. It's not hard, and we will go over it in class, I promise. Okay? I don't know why unit rate is in this chapter, but it is, and we're going to do it. Hang on. It sounds confusing. It looks confusing. It looks scary, but it's not too bad. A car travels 120 miles in 2 hours. Find the unit rate in feet per second. So we need to know how many feet in 1 second. That's our goal. Okay, they have the answer here, obviously, but I want to show you what they're doing to get to this answer. We need to do feet per second, which means 1 second. So they wrote the original ratio, 120 miles in 2 hours. Well, we don't want it in miles. We need it in feet. So the first thing we do is we take how many feet are in 1 mile. So we take the miles and we multiply them by feet to figure out how many feet are in 120 miles. So 5,280 feet in 1 mile. That's going to convert our miles to feet, which is where we want to be. Okay? We need miles to be converted to feet. If you wanted to do that down here, you could have done this just one step. You didn't have to do all these multiple steps. You could do this. It's going to give you some large numbers, but you could do this. Okay? Your miles cancel out. Okay? That's not, sorry, that should be hours. Your miles cancel out. Okay? Leaving you with 120 times 5,280. I'm not exactly sure what that is, but it would be your answer in feet over a 2-hour time span. So now you've just changed it into this many, you've driven this many feet in 2 hours. You've just converted from miles to feet. But now we want to get our hours to seconds. Okay? So in 1 hour, there are how many minutes? Let's start small. Let's go from hour to minutes. And then in 1 minute, there's how many seconds? Now, if you wanted to make it easy and you wanted to do just one step, you could do 1 hour. And then you could do 60 minutes times 60 seconds. Okay? And you would get, okay, so you could multiply this 1 hour equals 3,600 seconds. Because in 60 minutes, in each minute there are 60 seconds, so 60 times 60 is 3,600. Okay? So then your hours cancel out. You do the math, whatever this number was up here, this number that we don't know. Okay? You multiply that by 1 and multiply your 2 times 3,600. Divide that all out, and what you're going to come up with is 88 feet in 1 second. Now that seems like a really big mess, and we will talk about it. I hope you just wrote it down. No daily homework over that, I promise. Write that down, and we will do a couple of practice problems on this tomorrow, okay? All right, let's see what the video shows you. Unit rate is 88 feet per second. They're showing you all the work right here, just like I did. The hours cancel out. The miles cancel out, the minutes canceled out, and you just do the multiplication straight across. Anyway, we'll talk about it tomorrow. Don't panic. All right, here's your daily homework quiz. Okay, pause the video. Oh, I'm supposed to take the answers off. Okay, answers are now off. So you can pause the video. You probably saw that answer. And there's problem 2. Go ahead and pause the video if you need to write those down. And then here is number 3. Pause the video to write those down. Because I'm not going to let it just keep going while you write it down. So pause while you write that down. And I will see you in class on Wednesday. So, and bring any questions, okay? All right, bye.